Yes. So the question is, the first question I will take from initial value theorem. Initial value theorem, right? Okay. Question is, I'm writing question. Use. You can take a screenshot. Use the initial value theorem to find the initial value of signal corresponding to Laplace transform x of s, that will be equal to s plus 1 divided by s into s plus 2. Now this is the question. Question said that use initial value theorem to find the initial value of signal. So whenever they will say that initial value of signal means they want x of 0, small x. This is capital X. This is the Laplace transform of this. Or you can say that limit t tends to 0 x of t, right? So you initial value theorem, I am writing initial value theorem. So here I am writing initial value theorem. So initial value theorem means initial value, that is limit t tends to 0 x of t, can be written as limit s tends to 0 s x of s. That's it. So if you forget initial value theorem, please remember this statement, that initial value theorem means you are going to calculate the initial value, that is x of 0. And if you have given a Laplace transform of signal, right, that means what? That means you will use this formula. In this formula, s equal to 0. Okay, Amit. Okay, one two students have raised hand. Okay, yes, Amit, please tell, then I will complete my solution.
सर यहाँ लिमिट s टेंस टू 0 होगा सर
Huh.
RHS में.
Sorry, s tends to infinite. No, always remember, then if t is 0, if you are going to calculate initial value, then s will be infinite. And if you are calculating final value, that means x infinity, then s will be 0. So this is, you can say that, opposite part. So it is a good way to remember this initial and final value theorem. So initial value theorem means x of 0, when t 0, s should be infinite. And we have proved this one. And in the class, that is online class, on Monday or maybe Tuesday, we will discuss this one, and in 1 minute once, we will complete this proof, because we are revising the things. So in that class online, and it will be good. So here we will do a numerical part. Okay, so now, so if this is given, so from initial value theorem, look at here, you can write that limit s tends to infinite s x of s. Now limit s tends to infinite, that is s into, put this x of s, that is s plus 1 divided by s into s plus 2. S will get cancelled, and this will be limit s tends to infinite, and this will be s plus 1 divided by s plus 2. Now because when I will put infinity above, that means numerator and denominator, it will be, you can say that, infinite divided by infinite. So you know the concept of limit. We will divide by s, okay, numerator as well as denominator. So finally your result will be limit s tends to infinite 1 plus 1 upon s divided by 1 plus 2 upon s. And now this term will be 0, because s tends to infinite. This will become 1. So the initial value is 1. This is your result. So this is the basic question. That means not a difficult question, a very simple question. Now, so I am closing this question and I am writing next question, right? Okay. So the next question is, I think we should do one numerical on final value theorem. Clear? Clear? Okay. So next is, wait for a second. Next is, okay, finish. I hope you have taken a screenshot. Otherwise, I will send this one, no problem. Final value theorem. So one question we will do in final value theorem so that it will be clear, and proof we will see later on depending upon. If you want, then we will discuss in the class. If you do not want, definitely we will move further. Okay. Question is, question is second question of today class. The final value of x of t, that is 2 plus e की power minus 3t u of t, right, is, you can say that here it is obviously x of infinity is equal to 2, because when you will put t tends to infinite, this will always remain 1 because this is the unit step function, and e की power infinite minus infinity it will be 0, so the result will be 2. So it is obvious. Question is, so that this final value this final value can be found with final value theorem. Okay, so this is the second question, and now we are going to solve the question. So before solving this one, you should know the final value. So final value theorem value said limit limit t tends to infinite, that means final value x of t, or you can say that x of infinity, you can write limit, because here t tends to infinite, so definitely here s tends to 0, it will be there as x of s. So we have already done a proof of this final value theorem. We will do in offline classes, no problem. Okay, so we will use this one. So from this we can say x of infinity, you can write limit s tends to 0. Now this is small x, that is time dependent signal, or you can say that time signal represented in a time domain, and t will, I have written infinity. So but here I will write a frequency domain, you can say frequency representation of that x of t, it will be capital X. So it will be limit s tends to 0 s, and this x of s you have to calculate, but it is not given. So first you have to take a Laplace transform. That's why I have taken this question, because here direct, like here direct x of s is given, but here we do not have x of s. So in the, you know that the yesterday class, I have revised your Laplace transform. So Laplace transform said that it will be 2 times ut and plus e की power minus 3t ut. So I have told you that the Laplace transform of this x of t, which can be written as x of s, will be equal to ut is 1 upon s plus this ut is 1 upon s, so definitely e की power minus 3, तो ये हो जाएगा 1 upon s plus 3. If there is a minus, it will be plus. So you have easily calculated this one by the property. So now here you can write this one, so that will be 2 by s plus 1 upon s plus 3. I think this will be, orientation is absolutely correct. So finally, now limit s tends to 0, and that will be equal to 2 plus, and that will be equal to s upon s plus 3. So this will be 2, and this will be what? It will be 0. So answer is 2. So I think you have completed this initial and final value theorem concept. Okay. So this is the way through which you can solve a question. Okay. Yes. uh, I am going to give you one more question, then I will close this theorem, because it is very important to understand. You can say that another importance of this Laplace transform. So for that I will take one question, and then I will move in the waveform synthesis part. Clear? Okay. So again I am repeating, if you have any doubt. I think students are 44, that is more than enough. Fine. Next question is based on, again, initial and final value theorem, but here we basically explaining you the importance of Laplace transform in a system. Up, what is the meaning of that? Let us suppose you have one box. What is that box? Box means, let us suppose you have given some input signal x of t, and there is some operation like differentiation of xt, so you will get some output y of t, for example. Clear? So ht, so this is the, you can say that a box in which when signal will enter, it will process and you will have a some output. So I am giving some impulse response. So because I have not explained you what is the importance of impulse response and what is the impulse response, but right now please understood this point, that is the term impulse response. Impulse response, you can say that is a you property of system which explain the characteristic. For more detail we will discuss. Okay, because here if I will start discussing the importance of this impulse response, so the things will going to be change, and hum log numerical se we will deviate. So till now I can say that it will impulse response h of t represent the characteristic of system, characteristic of system. Like if you want to integrate, so there will be an integration. If you want to differentiate, definitely there will be differentiation, like this. Okay. Now if you want to calculate x of t, a y of t output, so always remember, if input is given and ht is given, then yt will be equal to xt convolution h of t. I have not told explain you convolution. ठीक, but it is, it convolution is a, again there is an operator, and the formula is x of tau h of t minus tau, and this will be like d tau. ठीक. So because we are not going to discuss, so I will not write, otherwise you will get confused. So simple, remember this one, whenever a whenever a signal is given in time domain, and impulse response is given in time domain, and you need to calculate the output, you have to take impulse response, sorry, convolution. Okay, fine. But if you know the Laplace transform, so what you will do, now this is the point, because you are we are discussing Laplace transform. So this is h of s, means Laplace transform of ht. For example, it is given. Now in this form it is not given. Let us suppose in a question they have given hs, and that is the Laplace transform of impulse response, and you can calculate x of s, because you know the Laplace transform. So the output will be in frequency response, and y of s, mathematically you can write x of s into h of s. Now look at here. Here you need to do some convolution, but here simply multiply input and impulse response in frequency domain, you will get output. And once you will get this output, you can take a inverse Laplace through partial fraction, जो कि we have already discussed. But no problem, we will because we are revising the things, so definitely we will revise that how to convert that frequency into that time domain. But here please try to understand that if you have given h of s, that is impulse response. Response means a characteristic. You, suppose somebody has given that h of, that means this is the characteristic of this system, like, okay. And if xt is given, then you can calculate x of s, or maybe x of s given, so simple ys will be multiplication of this impulse response and this input. Clear? I hope everybody understood. Now I am giving you a question. The question is find the final value of a response. Now they have asked yt of a system whose transfer function is h of s plus 3 divided by s square plus 4s plus 5, when system is excited by, the first is a unit step, that is x of t is equal to u of t. Second, a unit impulse, that is x of t is equal to delta t. Okay, now this question is given. Question में क्या है? Look at here. Uh, they have given this h of s. What is this h of s? The property of the system. It may be differentiation, it may be integration, it may be low pass filter, it may be high pass filter, it may be amplifier, whatever. Simple, it is given h of s. Now question is, you need to calculate the final value. That means this question is basically depending upon the final value theorem, right? Okay. And the written is that when system is excited by this, well, first is unit step, and in second time that means in this question we have two question. So you have to take xt as a ut, then impulse response is given, and you have to calculate the response, that means yt, right? So let's start. If you have any doubt, please ask question, because these are very important, very 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 important questions. I think you should not miss these questions. Okay. uh, Answer. Yes, Amit. Okay, I will take question, because then I will start. Yes, Amit, please tell.
सर थोड़ा बड़ा लिखिए सर, तो क्लियर नहीं दिख रहा है सर।
Acha, it is not clear. Okay, no problem. Okay. Okay, fine. So now I am drawing the system h of s. Clear? It is given, this one. And now the input is, that is system is excited by, the first is ut step. So definitely you know that the, because this is in frequency domain, so here we will write x of s, and because xt is ut, so this will be 1 upon s, because everybody knows that Laplace transform of this ut is 1 upon s. So this question consists two question. In one question you will write ut, and in another question you will write delta t. Then we will calculate this one, and you need to find out this y of s. So I have already told you that in frequency response, ys is nothing but simply multiplication of these two. So this can be written as x of s into h of s. So 1 upon s into h of s, that is s plus 3 divided by s square plus 4s plus 5. Look at here, right? So you need to calculate the final value of this, because it is written final value of vt. So final value, final, sorry, it, final value of yt is nothing but limit t tends to infinite y of t or y of infinity. So this, you know that it is limit s tends to 0 s into x. Now because here it is yt, so here will be y of s. Okay, so put this value. So I am writing here. So limit s tends to 0, 1 upon s into s into this term, s plus 3 divided by s square plus 4s plus 5. S will get cancelled. Put this s equal to 0, because this is infinity, this is as 0 0 0. So your answer is 3 by 5, your answer. So this is your 3 by 5 is your answer. I hope everybody understood. This is answer number A. Clear? Okay. Now answer number B. So in this B, again you will make a system. So h of s, but now in this case xt is delta t, and I have already told you that delta t का लाप्लास ट्रांसफॉर्म 1 होता है, तो you can write x of s is equal to 1. Why? Because the Laplace transform of delta t, I have proved that one. Please take your notes, previous notes. So that's why I written, and this will be y of s. So y of s is nothing but 1 into this, that is s plus 3 divided by s square plus 4s plus 5. Clear? And it will be 1 upon s multiplied. Clear? No, 1 upon s we will not multiply, because this is 1 and this is h of s, and h of s is given as plus 3. So this is your this one. Clear? So what is y infinity, or you can say that what is limit t tends to infinite y of t. So you can say that limit s tends to 0, because if this is final value theorem, so infinity, so it will be 0 s s plus 3 divided by s square plus 4s plus 5. When you will solve, you will get 0 answer. So I hope everybody understood. These are very tough questions, it is not easy questions. Um, so I think you should have completed this one. Okay, so now I think it is more than enough to discuss questions. Now I will discuss a waveform synthesis part. Okay, and wait for a second so that I will open that questions. Okay. Hmm. So the question is, अगला क्वेश्चन जो नेक्स्ट क्वेश्चन वेवफॉर्म सिंथेसिस पे पाल, ठीक है. So I will take one question. Okay, and that question should be, wait for a second, I will take one important question. Okay, now question is, question is question obtained, obtain the Laplace transform, obtain the Laplace transform of the square wave train. I know that when I was ended my lecture, I think 15 days ago, I was discussing some, you can say that, graphical approach to calculate this Laplace transform. So question is, I will draw that diagram. So the diagram is like this. This is your diagram. It will be like this. This is your square wave. This is your square wave, right? This is like x of t, and this is t, right? This is t, this is 2t, this is 3t, this is 4t, like this 5t, 6t, and so on. And this value is given in point. Clear? It will be like this. So if I hope everybody understood this point, again it will be minus 1. So you need to calculate the Laplace transform of this periodic signal. Okay, fine. How you will approach? So approach is very simple. You will write this, you can say that, mathematical expression of this waveform, and that is nothing but waveform synthesis part. So how you will write this? Okay, so for that I will, first of all, I will see, because writing this mathematical expression of this equation is very easy, but for that you need to understand few basic things. Okay, so I will start from a basic point. So and then I will come to this question. Question is, for example, I have written simply this one. This is 1 and this is t, and this is small t, and let us suppose this is x1t. If I will ask you, okay, write the mathematical expression of this waveform, so how you will write? First of all, understood this point. So expression will be, look at here how I will write expression. Up for that, what you will do? This x1t can be written as ut ut minus u t minus 1. Now question is, how I have written this one? So for that, a very small idea. Look at here. Let us suppose I am going to draw two signal. One is u of t. So graph of ut is like this. 1. And this, let us suppose u of t minus 1. U of t minus 1, I have told you that whenever you have to draw, you have to shift your signal by any value. If this is the negative, that means you are shifting into the right direction, like this one. Okay, and how you can say this one, that u of t, if you can write, this is 1 for t greater than 0 and t less than or equal to 0. So u of t minus 1, you can write, it will be, sorry, it will be like 1 for t minus 1 greater than 0 and t minus 1 less than or equal to 0, that will be 0. Okay, so similarly you can write this one, that is u t minus 1, you can write 1. Now this t minus 1 greater than 0 means t greater than 1, and t minus 1 less than or equal to 0, that means t less than or equal to 1, and this will be 0. So from this you can say that mathematics, that means we have replaced this t by t minus 1, and then we have solved this one. So from that we have drawn this diagram. Look at here. So what I have did, t greater than 1, this will be 1. Look at here, it will be 1. Okay, and t less than or equal to 1, less than or equal to 1, it will be 0, like this will be 0. Clear? Now if I will subtract these two, that means, so what I will get the result. Okay, so wait, so okay, if I am subtracting, so look at here, 1, this part, this part, this part, before 1, this is 0, this is 0, 0 minus 0, you will get 0. Clear? This is what? This is ut minus ut minus 1, right? Okay. 1 minus 0, because this is 0, so you will get 1. It will be like 1, this one. And then 1 minus 1, so you will get again 0. Look at it. So this is your graph. It is similar to, it is similar to this one, right? The only thing is that here it is t. So if there is a t, so if I will replace this 1 by capital T, so this will be t small t minus capital T, so the whole will be shifted here, so it will be like this. So here you can say that it will be u t minus capital T. I hope you everybody understood my point, that x1t is equal to ut and ut minus 1. Clear? Okay. Now next point is, I am giving you another graph and you need to answer this, because see, again I am repeating that at the end of this whole discussion, uh, I will not you I will give you a shortcut through which you can solve, you can write very quickly the equation, but you have to understand that why I have written this one. Okay. Next is, next I am writing, suppose I am drawing a signal x of t, and it will be like this. It will be like this. Wait, Kush. I am counting. This is minus 1, and this is t, and this is 2t. Now you need to answer this one. Okay, then I will continue. Okay, yes, tab tak Kush का answer. Yes, Kush, please tell.
सर
Yes, Kush.
सर ये एक बार बता दीजिए यू टी माइनस वन जो यहाँ राइट हैंड साइड पे नहीं लिखे हैं सर.
अच्छा. I'm repeating that one. Okay.
ओके सर.
Look at here. See, I am repeating the whole thing till now. If you understood this point, please calculate the waveform and write and send me a message or raise your hand after. तब तक मैं ये बताता हूँ. देखिए, this is ut. So I am explained many times that unit step function will be represented like this. When you will shift, इसको कहते हैं right shift. When you will, you can say that subtract something in t, then your graph, either it is unit step or it will be delta or it will be a ramp function, the graph will be shifted by right by this unit. Remember one, that means x of t and x of t minus capital T, capital T, that means your whole graph will be shifted by capital T. If you will write t minus 2 times t, your whole graph will be shifted by 2t, here like this. If you will write 2, so your graph will be right shifted right direction by 2. That means if there is a minus sign, then whole graph will be shifted towards right direction with this. Okay, मतलब you can quantity, ये याद कर लिए, remember. And what is the proof of that? Look at here. What I have did, ut I have written, and let us suppose ut minus 1. That means here I am writing ut minus capital T, for example. So what I am going from this definition, I will replace this t by t minus t. So this is also be replaced by t minus t. So it will be t minus capital T. And similarly, this small t can also be represented by t minus capital T, because the complete small t is represented replacing by t minus is capital T, right? So now when I will solve, look at here, this will be capital T, this will be how this is the capital T will go right side inequality. So this inequality will become t greater than capital T. Similarly, this capital T will go right side. So this small t is less than or equal to capital T, and this will become this one, right? So as you can see that a very simple explanation is that whenever you will subtract something in t, I am saying that t, the whole graph will be shifted towards right direction. And this is the proof that for t greater than capital T you will get 1. That means t greater than this capital T you will get 1. So whenever I will subtract something inside the function x of t hai, and if I will write x of t minus 1, the whole graph will be shifted towards right direction with 1. Like here it is capital T, the whole graph will be shifted by capital T. I think Kush understood this point. So when you will subtract these two, look at here, this is a 0, this is also a 0, so 0 minus 0, it will remain 0. Now this is 1, and here this capital T, let us suppose this is capital T, so this is 1 and this is 0, so 1 minus 0, it will be 1. Clear? This will be, and then you can say that it is 1, and after t this function is also 1, so 1 minus 1, it will be 0. So ut, that is ut minus ut minus t, it will be 0. So the whole graph will be, you can say that it will become a pulse having value 1 for 0 to t. Course, please raise your hand and tell me whether you understood this point or not. And yes, course, please.
Yes, sir. Understood.
Okay. So in offline class you can ask this question. I can repeat that one because online classes may it will take very less time to discuss this one. Okay, now please try to solve this one and explain me that what happens with this graph. If anybody have solved, then please write down the equation. Otherwise I will explain. किसी ने अगर क्वेश्चन सॉल्व कर लियो, किसी का भी आंसर ने हाथ रेज नहीं हुआ, ओके नो प्रॉब्लम. How you will approach this one? Please try to understand that this signal is basically, you can say that we have made in downward. Okay, so we have 5 minutes, and within 5 minutes we will complete this one. Then these equation will become quite easy. So for that, what I am going to tell you, एक छोटा सा आपको एक idea देते हैं. Look at here. If your signal is like this, and if you will x of t, let us suppose this is x of t, it is not visible, so I am taking another page and here I am writing. Let us suppose you have a one signal like this x of t, this one. And if I want to draw minus of xt, what happen? The whole graph will be shifted downward. This will be the minus of t. That's it. Please look at here that if this is given, and if somebody take minus of this, that means the whole graph will be inverted. And how? Look at it. This is suppose kariye 1 and you will have 2 value. So when I will multiply minus, you can say that but minus 1, so this 2 will become minus 2, so graph will be minus 2 and that will be equal to 1. Take like this 1. So the point is that whenever somebody asks you to draw this, better to draw this one and then multiply by minus 1 in a whole, you can say that signal. Understood my point? Again, I am repeating that if you have difficulty to draw um, a difficulty to explain a mathematical expression of this, better to write mathematical expression of this and then simply multiply by minus 1. अब आते हैं इस question. So the question which is given is this one. this is t and this is 2t, and this is like you have to read suppose it is x of 2t and this is small t. You need to draw this one. So better, what better? So better is to draw this one and then I will multiply. So it will be better to draw this one. For example, this will be, this is t and this is 2t. And how you will how you will, you can say that write equation, simple equation is that ut, now ut minus t, then your graph will be shifted by t. ठीक? And second equation you can write ut minus 2t, that means your ut graph will be shifted by 2t, it will be like this 2t. Now, when you will subtract, look at here, t and 2t. So you have written ut minus capital T, you have written ut minus capital 2t. Now, when you will subtract this one, so your graph will be, this is 0. So here this is t, so this will be 0, 0 minus 0, it will remain 0. Now this is 1, this is up to this point 2t. So this is 1, this is 0, so 1 minus 0, it will remain 1, and 1 minus 1, it will remain 0, t and 2t. So what is the equation of this? U of small t minus capital T minus u of small t minus 2t. आपको आंसर आ चुका है. And yet, when you will multiply this whole function by minus, the graph will be shifted. That means finally, if you will multiply, your graph will be like this. It will be like this when you will multiply, that is minus of ut minus t, and this minus will become plus because when we multiply, so this will be u of t minus. So this will become T and capital T. I hope everybody understood my point. So finally, you can write the equation here. Look at here. So equation you can write this x of 2t. X of 2t, you can say it is minus the whole bracket u of t minus capital T minus u of t minus capital T. Completed. Clear? Now, if simply I will ask you what is the graph, you can say that, like for example, this is 2t and this is 3t, and if I will write x of 3t, and it will be like this. So what will be the equation? I think you should write directly. This is 1. This is also 1. So you can write x of 3t. It will be, now this is 2t. This is 2t. So simply you can write my t minus 2t minus of u of t minus 3t. And if somebody asks you that it will be downward, so what is the expression? So you will simply multiply. So when you will add all these things, it will become like, which we will discuss in the next class. Okay, so thank you very much. If you want to take a snapshot, please take it.